Okay, so we've got a question here. We need to integrate this complex function 1 over 2z minus 3i times 2z minus 5i with respect to z. And we're going to do it over the closed contour z equals 4. So that's the modulus of z. So if we just draw that up on here, z equals 4 can look something like this. That would be 4, that would be 4i, minus 4i, and that would be minus 4. So we can see straight away that this is a closed contour, a simple closed contour. So that's one thing we know about that. And then we know we can enclose that in another simply connected region, which is simply maybe out to 5. So this could be 5i, and that could be 5. It's not to scale, but it just shows what we can do. Now the way to work this out would be Cauchy's residue theorem. Now the integral formula is not going to work because we've got 2 poles in here. So first of all, we need to find the residues. So how are we going to find the residues of this? So let's let f of z equal 1 over. Now for the residue theorem, we can't have the 2z. We need to factor out the 2. So we're going to have 2 times z minus 3i over 2. And the same again here. 2 times z minus 5i over 2. And then what we can do, we can use the cover-up method and cover up each one of these at the singularities here. So you can see this function here is analytic everywhere except when z is 3i over 2 or 5i over 2. So we can say singularities at z equals 3i over 2 and z equals 5i over 2. Okay, so let's go with the cover-up method. Let's find the residue of f at 3i over 2. So plugging 3i over 2 into here. So that means this will disappear. Then we're left with 1 over the 2 stays. This 2 stays. And then we've got 3i over 2 minus 5i over 2. So 3i minus 5i is minus 2i. That then just becomes minus I over 2. Sorry, minus I. So then that would be equal to minus 1. Sorry, minus I times 4, so that's minus 1 over 4i. Okay, so that's our first residue. Next residue we're going to find is at this one, 5i over 2. Okay, so this time we plug in the 5i over 2, which will cover up this one. And we'll then be left with 1 over 2 stays. 5i over 2 minus 3i over 2. That just leaves us with 2i over 2, which is I. And then this 2 here. Let's just put the multipliers in there so you can see. Okay, so then that leaves us with positive 1 over 4i. Okay, so that's the residues found out. So now Cauchy's residue theorem, let's just write that down here. Basically, the answer will give us the answer to this integral over c of f of z, so that's our function, that's the same as this, dz equals 2 pi I, and then you multiply the sum of the residues. So we multiply by residue f3i over 2, which is minus 1 over 4. 1 over 4i, that is, plus 1 over 4i. Just rub that out for now. Let's just keep it in there, we just put the 2 like that. Plus 1 over 4i. Okay, so 2 pi I, that's fine. Minus 1 over 4i plus 1 over 4i, that is 0. Interestingly, this integral is 0. Okay, that's Cauchy's residue theorem.